we want to look at two more examples of interference, and the first one is gasoline floating on water, or it could be oil floating on water. So if you look at the picture, top picture off to the right, that's a picture of a boat, and you should notice that there's an oil sheen on the water, and you can see the different colors in it. So what is it that's going to be making those colors? So we're going to have water. So this is the surface of the water, and then floating on top of it is going to be oil or gasoline. So that we're going to have light that is going to be coming in like this, and some of that light is going to bounce off of the gasoline and then go into your eye. But some of it is going to go through the gasoline and then bounce off the water and then go into your eye. You want to take a look at that? So what do you think that is? So you notice that this one is cresting while this one is troughing. I have no idea if that's even a word, but it sounds pretty good to me. Troughing. And so they are canceling each other out. So that would be destructive interference. So that particular color would be missing. You wouldn't see that color at all. Okay, but let's say it's white light, and this just happened to be blue. So blue is destructively removed. So it would be white light minus the color blue, and then that would be a different color of light. So notice it depends on the angle that the light is coming in at. It's going to depend on the thickness, so that's going to be the distance, and it's going to depend on the wavelength of the light. So exactly what we predicted before, so we go back to here, that interference depends on the wavelength of the light, depends on the thickness, the distance it's traveling, and it's also going to be depending on the angle that it makes. So this is what's really cool about this, is that means that if you are looking at a particular patch of oil and you say, well, that's red, somebody else looking at that same patch would say, no, that's green. You're crazy. And you're both right, because you have different angles that you're looking at. So it's the same color coming in, it's the same thickness at that point, but depending on your height, you might be viewing it at a different angle, and so it might look like it's a different color. Now the one that is underneath it is a soap bubble. So a soap bubble is going to be a certain thickness. So this is the outside of the soap bubble, this is the inside of the soap bubble, and then this is the soapy part right here. So that light could come in and it could bounce off the top part here and then go into your eye. And then light could come in and it could bounce off this one and then go into your eye. Would that be constructive or would that be destructive? So you notice this one is going down and this one's going down at the same time, so that's going to be constructive interference. So you are going to see whatever color of light that is, but it could end up being destructive as well. So notice both of these are basically the same principle. It's going to depend on the angle at which you're looking at, it's going to depend on the thickness of the soap bubble, and it's going to depend on what color of light is hitting the soap bubble. And so the picture that is on the bottom and over to the right is a picture of soap bubbles, and you notice that they have different colors to them. And all of this is an example of interference. All right, let's take a break. And when we come back, we're going to look at diffraction.